We're going to be looking at Pascal's triangle and the binomial theorem. With Pascal's triangle, what we notice is that there's a pattern. And this pattern describes the multiplying of binomials. So when we have a binomial, x plus 1 to the 0, it gives us a coefficient of 1. When we have x plus 1 raised to the 1, it gives us coefficients of 1 and 1. Now, when we have x plus 1 squared, what we do is we FOIL it. And when we FOIL it, we get x squared plus 2x plus 1. Notice the coefficients, 1, 2, 1, 1, 2, 1. So Pascal found out that the coefficients follow a certain pattern, and it actually makes up a triangle. So we have 1, we have 1, 1, we have 1, 2, 1, we have 1, 3, 3, 1. Now, how this works is if you add the 1 and the 2, it gives us a 3. The 2 and the 1, it gives us a 3. The 1 and the 3 give us a 4. The 3 and the 3 give us a 6. And the 3 and the 1 give us a 4. So if we were trying to find degree 5, it would be 1. It's always 1 on the outside. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So we could find the coefficients of any binomial by this pattern. Now, there's actually 3 patterns when we're expanding a binomial. The first one is the coefficients in the front. The second one has to do with our a value and our b value. So if we're talking about a binomial, what I do is call the first one a and our second one b. Then the degree is based off of our exponent. Let's call it n. So for our example problem, our n value is 4, so it's degree 4. Now, with the first term, our a value, we go in descending order, x to the 4th, x to the 3rd, x to the 2nd, x to the 1, x to the 0. In our b value, we go in ascending order, b to the 0 or negative 2 to the 0, negative 2 to the 1, negative 2 to the 2, negative 2 to the 3, and negative 2 to the 4. Now, because this is degree 4, notice that when we're looking at degree 4 on Pascal's triangle, our coefficients are 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Then what we do is we multiply them. Anything to the 0 is 1. 1 times 1 is 1, x to the 4th. 4 times negative 2 is negative 8, x to the 3rd. Negative 2 squared is 4. 4 times 6 is 24, x squared. Negative 8 times 4 is negative 32, x. And negative 2 to the 4th is 16, times 1 is 16. So that's how we expand binomials. So let's look at our example, x plus 4 raised to the 3rd. Now, remember, there's 3 different patterns. Our first pattern is our coefficients. Since it's degree 3, we're going to be looking at 1, 3, 3, 1. So our first, our second, our third, and our fourth. So we're going to have 4 terms. We're going to take our a value, that's our first value, so x to the 3rd, and then we have 4 to the 0. We have x to the 2nd, and 4 to the 1. We have x, and we have 4 to the 2nd. And for our last one, what we have is x to the 0, and we have 4 to the 3rd. Now, one interesting thing to notice is that these exponents always add up to what our n value is, or our whatever our polynomial is raised to. 2 plus 1 is 3. 1 plus 2 is 3. 0 plus 3 is 3. So they all add up to 3. Now we're going to multiply it out. Anything to the 0 is 1. So we have x to the 3rd. 4 times 3 gives us 12x squared. 16 times 3 gives us 48x. And 4 to the third is 64. And that right there would be our answer. Now looking at letter B, this is a little bit more complicated. It's degree 5, so that means that when we look at Pascal's triangle, it would be the 1, 5, 10, 10, 5, 1 combination. So we have 1, 5, 10, 10, 5, and 1. We're going to look at 2x, and we're raising it to the 5th power. And then we take the negative 3 and we raise it to the 0. We take the 2x, remember we go in descending order, so instead of 5, it is now 4, and our negative 3 is going in ascending order, so instead of 0, it's 1. Remember that these exponents are going to add up to whatever we have here as our end value, in this case 5. So notice that they're all adding up to 5. So we have 2x to the 5th, 2x to the 4th. This now is 2x to the 3rd. Negative 3 to the 2nd. We have 2x to the 2nd and negative 3 to the 3rd. And then we have 2x and to the 1st, and then negative 3 to the 4th. And our last one, 2x to the 0 and negative 3 to the 5. Once again, these exponents, notice they're all adding up to 5, and they'll always add up to whatever our degree is if we're doing it correctly. So now what we're going to do is we're going to do some multiplying. We have 2 to the 5th. Anything to the 0 is 1. So 2 to the 5th is 32, and then x to the 5th. Here we have negative 3. 2 to the 4th is 16. So we have 16 times 5 times negative 3. And that gives us negative 240, x to the 4th. 2 to the 3rd is 8. And then we times it by negative 3 squared, which is 9. And we times it by 10. And that gives us 720. X to the 3rd. Now, one thing to remember, and this is where I usually make a mistake, is when is it negative, when is it positive? Remember, if you're raising a negative to an odd, it's going to be negative. When you're raising a negative to an even exponent, the two negatives are going to cancel to make a positive. That's why this is positive. So with this next one, notice that this is negative 27. So we're going to take the negative 27, we're going to times it by 4, and then we're going to times it by 10. And that right there gives us negative 1080, x to the 2nd. For the next one, we have negative 3 to the 4th. That gives us a positive 81 times 2 times 5. That gives us 810, x. And then for the last one, negative 3 to the 5th, we know is negative. And that would be negative 243. So looking at letter C, we're going to do the same thing. This is degree 4. So degree 4 is going to be 1. And then what we have is we have 4, 6, 4, and 1. We have x to the 4th and negative 5 to the 0. We have x to the 3rd. We have negative 5 squared. We have x to the 2nd. We have negative 5 to the 3rd. Sorry, I made a mistake. That should be a 1. And this should be a 2. That makes more sense. Notice that I caught myself. This should add up to 4. That adds up to 4, adds up to 4. This should also add up to 4. I have x to the 1, and then what we have is negative 5 to the third. And the last one is x to the 0 and negative 5 to the fourth. So anything to the 0 is 1. So we have x to the fourth. Negative 5 times 4 is negative 20, x to the third. 25 times 6 gives us 150, x to the second. We have 125, and we multiply that by 4, and that gives us 500. And for our last one, we have 5 to the fourth, which is 625. Next thing that we're going to look at is we're going to look at the binomial theorem.